This video is sponsored by PCBWay. Hello there and welcome back to another video. In today's video, I'm going to be repairing another computer that I bought on eBay as broken recently. This right here is an Acer Aspire small form factor desktop computer. Its exact model is the D17E6, I know, really catchy, and this one in particular has an Intel Core i3-10105 CPU in it, alongside 8GB of DDR4 RAM and a 256GB SSD. According to the seller, when they attempt to power the system up, it lights up and the fans spin, but it doesn't send any signal to the monitor. They also say that the computer makes a ringing sound when it's plugged in, and from their research, they think that it could mean that it has a faulty fan. I will say, I'm really not sure what they mean by a ringing noise, as I don't know of any computer noises that I'd describe with that word. But I guess we'll find out once we power the system on and figure out what's going on inside it. Except I'm actually going to open up this computer first, as I think there's an issue already. And I say that because I can hear something big rattling around inside this computer's case that I'm guessing must have come loose in shipping. And in this case, the whole 8GB stick of DDR4 RAM had come out of its slot at some point and had been banging around in the system for who knows how long. But alright, that's not too big of a deal, just pop the RAM stick back in and start troubleshooting, right? Well, actually not so fast. Having something banging around in a computer like this, especially throughout the shipping process where the boxes are being thrown around pretty intensely, could have very likely damaged some other parts of the computer like the motherboard, where it could have chipped off an SMD component or two. And unfortunately, I did find a chipped off capacitor in the bottom of the case. Thankfully, after looking for where the capacitor could have come from, I found that it came off of the DIMM itself and not the motherboard. So if I'm not able to repair the missing capacitor, it should be an easier repair than having to find a replacement motherboard and do a motherboard swap, even though losing a DIMM in this economy is really brutal. Apart from this missing capacitor on the DIMM, I didn't see any other damage inside of the computer though, so it looks like this might be all that happened, in which case we got pretty lucky. So with that information, I'll go ahead and I'll solder the capacitor back onto the RAM stick because, I mean, we all know what's happened to RAM prices and I don't think I can afford not to. So let me just take the capacitor and shoot. Yeah, it was gone after that. I looked for a while, but I completely lost the capacitor. Thankfully, it appears to be a standard decoupling capacitor for keeping the power clean at each individual RAM chip, which means a few things. One, I can temporarily pull off one of the other decoupling capacitors, measure it, and then replace this capacitor with something I have on hand that matches that other capacitor's value, as due to its application and the pattern on this PCB, it's incredibly unlikely that this cap is a different value than the other ones that are in the same position on the different RAM chips. And two, even if I don't have a perfect value or physical size capacitor to replace it with, it's very unlikely to cause any issues if I have to get a little bit creative. And of course, I can verify that it's all good with a memory test. And three, there's a chance the RAM stick will work fine without this capacitor at all, though of course that's still not ideal. So I'll get to fixing that RAM stick in just a moment here, but obviously the main objective of this video is to get the whole computer working. So I'll grab a different DDR4 RAM stick and throw that into the system so we can see what it does. After tossing this DIMM into the computer and powering it on, it actually powered on completely normally. And it even booted into Windows, where I shortly discovered that the previous owner didn't wipe the system before getting rid of it. I mean, I guess I can kind of get it, as they couldn't access the computer to use the reset this PC option because it wouldn't turn on, but come on, look up how to protect your data and do it, people. If these computers end up in the wrong hands, you could be leaving yourself open to all kinds of fraud and even identity theft. Let's remember the computer I got once that had both an unlocked profile and pictures of the front and back of the owner's driver's license right there in the center of the desktop. Yikes. Alright, well, I'll be running a secure wipe on that SSD in just a minute once I'm ready to start getting this computer ready for resale. But now that I know the rest of the system works, I'm curious to see if this damaged DIMM will work in the system with that missing decoupling capacitor. It's unlikely that that capacitor will completely brick the RAM stick, in my opinion, so let's see if it works just for the sake of exploration. And as I expected, the DIMM posted just fine. This didn't surprise me because with that knocked off capacitor just being a decoupling capacitor and there being several more of them on the board, it was just unlikely that there would be enough electrical noise in the power bus to keep the DIMM from working. And to go a little bit more in depth, because I like to be nerdy on this channel, a decoupling capacitor, also sometimes called a bypass capacitor, is generally just a capacitor between a positive voltage rail and ground. And its purpose is to ensure that the power to a section of the circuit, usually an IC chip like the RAM dies, remains stable even if the power on the power bus gets a little bit jittery, as both the IC itself and other parts of the circuit draw current from it. Usually, you'll find many of these on each power rail in circuits, especially in computers, but they're usually physically located close to the chips that they support. So in the case of this DIMM, there are several capacitors across the power and ground rails for the RAM dies, but they're just spaced out around the board so that each one can support each individual die better. This means that the die that doesn't have its capacitor anymore doesn't suddenly have zero capacitance on its power rail, as the capacitance from the rest of the decoupling capacitors is still present on that rail and available to the chip. It's just physically farther away from the die, and therefore a little less effective for stabilizing its power due to things such as parasitic resistance and inductance. And if these kinds of intimate details on how the electronics we use and love interests you, I think that there's a strong chance you'll enjoy the services that today's video sponsor, PCBWay, has to offer. PCBWay is a company that offers high-quality custom manufacturing services, and their portfolio includes processes such as PCB manufacturing and assembly, CNC machining, 3D printing, and much more. They make it incredibly easy to turn your designs into a real, professionally made part, whether you're designing parts for a fully custom project or if you're modeling something to repair a broken appliance. PCBWay is almost certain to have a service that can do what you need in any of those cases. I've used PCBWay's products countless times before, and I've always been extremely pleased with the quality of their products, and they've never failed to bring my projects to life in a professional way. So if you're interested in designing and building things, or fixing the stuff that you already own, definitely check PCBWay out at the link in the video description. In any case, I'm not going to just leave this DIMM in the system with that capacitor missing. I can do better than that. So out comes the microscope and the soldering iron, because we're going to be doing some very basic board level repair today. The first step in this process will be to remove one of the other decoupling capacitors from the board so that we can measure its capacitance and choose a suitable replacement capacitor. After one was desoldered from the board, I was able to use a set of LCR meter tweezers to find out that this capacitor is approximately a 5.1 microfarad capacitor. Sweet. So now I can find a similar value capacitor to replace the missing one, and then I can solder this one back onto the board, and oh, you've got to be kidding me. Yep, I lost that one too. I probably shouldn't have taken such a long break from working with SMD parts, as my tweezer skills have definitely become subpar in that time. But whatever, I got the information that I need to know the value of capacitor to replace both of these caps with, and hopefully I have something on hand that's not too exorbitantly oversized in terms of physical packaging. So after digging in my parts collection for a while, this is what I came back with: a couple of 4.7 microfarad 1206 package capacitors. These are very slightly lower capacitance than the ones coming from the board, but not by much at all, and for decoupling, this should be alright. The larger issue, literally, is that they're a lot larger than the ones that came off the board. Thankfully, this shouldn't affect performance and will only be meaningful in the context of actually making the physical connections to the PCB with solder. But with the help of solder flux and patience, I was able to make it happen, even though it's not necessarily pretty. So let's toss this stick back in the system and see if it posts. And then, of course, do the responsible thing and run an intensive memory test on it to make sure that that DIMM is actually in good, functional condition and is ready to return to service. Now, unsurprisingly again, the DIMM posted just fine in the system, and this wasn't a surprise considering that it worked without the capacitor at all before. So after confirming that the system would boot, I then grabbed a Linux Mint install USB, as this has a built-in memory test that you can select from the Grub boot menu. After letting that run for its full time, the system returned a big green pass banner and let me know that there were 0 errors during its test. So I'd consider that a win and say that this DIMM is ready to return to service. Sweet. So the system is fully functional once more, but what even went wrong with this thing in the first place? Well, I don't think I'll ever be able to know for sure, but here's my hypothesis on what happened. I think that the system might have been suffering from a RAM stick that had come partway out of its slot. This can happen to these desktop computers if they're dropped or knocked over when standing vertically, and it's very common computer knowledge that an unseated RAM stick can completely stop post and therefore display to the monitor like the seller described. I will also say that when I was testing the system, I didn't hear any ringing sounds, the system didn't beep at me at all, and the fans in the system were working fine and were silent. But if the RAM stick was partially unseated when the seller had the system, there's a good chance that it could have been beeping at them, and that might have been what they were talking about. All of this also aligns with the fact that the RAM stick came fully out in shipping, as a fully seated RAM stick would almost never do this, especially one that's really lightweight like this because it doesn't have a big metal heat spreader on it. So I think that the RAM stick was already partially dislodged by the time that the system was shipped, and that's how it ended up coming out fully. But yeah, that's the repair on this system and what I think might have gone wrong with it in the first place. If that's all that you were here for in this video, feel free to move on to working on whatever else you're working on now. It was good having you. But if you want to learn a little more about this system, keep watching, because I'll be running a couple of benchmarks and exploring its internals a bit, and I have to say, Acer impressed me with this one. So let's start with an almost full teardown of the computer, where I noticed that, sadly, this computer doesn't exhibit any convenient toolless release mechanisms like the Dell Optiplex and Precision computers do. But honestly, this is fair, as it's clear that this computer was designed for home office use, where these features are unlikely to be needed at all. After I got the front panel off, as well as the drive cage, which has room for one 3.5-inch drive and one 2.5-inch drive in it, I was able to have a full view of the motherboard. This motherboard only has one M.2 NVMe slot on it, and installed in it is a 256GB Western Digital SN530 SSD, which is a good enough drive for this case, even though it doesn't have a DRAM cache. I'm going to be taking this drive out of the system for now and securely wiping it on a separate computer to get rid of all of the previous owner's personal data. And in the meantime, for my testing, I'll install one of my own 256GB SSDs. Moving on from the NVMe slot, this system comes with 2 RAM slots which allow up to dual channel DDR4, and this system does support JEDEC 3200 memory as well, as that's what the DIMM that came in it runs at when installed. As for this computer's power supply, like with almost every single SFF desktop you'll find since Intel's 4th generation chips, it's proprietary. However, Acer has done something interesting here, as this power supply is actually a 300 watt 80+ bronze unit, which doesn't sound too interesting on its own until you realize that this has plenty of headroom for a low profile, slot powered graphics card. Much more headroom than the 200-ish watt units that come in all of the Dell small form factor computers. Continuing with power, something else that I noticed in this system is that even though the power supply itself only has a 4-pin CPU power connector, the motherboard has an 8-pin plug, and I found online that this model of computer could be spec'd with up to an i7-11700, so it's likely that in that configuration they'd use a full 8-pin EPS cable to connect to the motherboard. In line with this optioning as well is the fact that the VRMs on this motherboard actually look really quite decent. They don't have their own heat sinks or anything, but the style of cooler used here will provide plenty of airflow for them, and therefore I wouldn't be too concerned with cooling or performance for them. Also, with the cooler, for this CPU, it looks plenty adequate. I'd be concerned with an 11700, but maybe they put a thicker heatsink in that version. I will say, I'm pretty sure this cooler has a bigger central core and definitely a bigger fan than the cooler that was in the Dell Precision 3660 I checked out a couple of weeks ago. And Dell put that cooler on an i7-13700. The final thing that I want to cover before reassembling the system and running some tests on it is that Acer did something that, in my books, has earned them so many points over Dell, HP, and Lenovo. They actually put the PCIe X16 slot on top of the smaller X1 slot. Dell, HP, and Lenovo, at least in all of the computers I've used from them since Intel 3rd generation, have put the PCIe X16 slot at the bottom and the X1 or X4 slot at the top for absolutely no reason other than to stop people from installing a dual slot, low profile card into the system. Acer has done what I consider to be the right thing and placed this slot where it can be fully utilized by a dual slot GPU. And with a power supply that can support that extra 75 watts without any questions asked, there's no way I can pass up the opportunity to toss the 3056 gig in here and run some gaming tests. So let's get to that. But real fast, I would like to do a standard Cinebench test because I haven't seen this CPU on my bench before, and I want to see how it performs. Also, I should mention at this point that all of the tests I'm doing today are with that single 8GB DDR4 stick installed, which I know would hugely benefit from being upgraded, but I am both genuinely curious what we get with the stock config here, and trying to put another stress test through this DIMM before I call it good. In Cinebench R23 running on a fresh Windows 11 installation, the i3-10105 managed a multi-core score of 5122 points, which is nothing exceptional, but plenty for some light gaming and general office work. In terms of single core, this CPU managed 963 points, which just barely beats out the Ryzen 7 1700X. Now let's move on to the 3 games that I tested today: Halo Infinite, Satisfactory, and Spider-Man Remastered. Starting in Halo Infinite, this system managed an average frame rate of 87.5 FPS at 1080p medium settings, which is plenty usable in this game, even with it being a competitive shooter. The 1% low was 52.5 FPS, and the 0.1% low was 40.6 FPS, indicating a very stable frame rate as well. Moving into Spider-Man Remastered, this game ran surprisingly poorly at high settings, but not because that's too much for the GPU. Instead, the CPU was the main bottleneck here, and I'm wondering if the RAM is playing much of a role in this, as I feel like this chip should perform better than it is currently. Regardless, the average frame rate was 35.7 FPS with a 1% low of 12.9 and a 0.1% low of 0.7, which is pretty brutal. And finally, let's check out Satisfactory, an Unreal Engine 5 game that's always pretty hard to run. At 1080p medium, this system managed an average frame rate of 41.3 FPS, with a 1% and 0.1% low of 3.5 and 1.3 FPS respectively. Those percentile lows are a little bit worse than I'd usually expect from this game, even though it's naturally pretty stuttery. And that 41.3 FPS average isn't exceptional either. This all seems to, again, be the result of a CPU bottleneck though, as the GPU utilization was rarely near 100% and the CPU was almost always right up there. So not a crazy great performance in games overall. But here's the thing, this system is the most expandable small form factor office PC that I've seen so far on the channel, minus maybe a Dell Optiplex 990 or 7010. But those are second and third generation Intel platforms respectively, so really not great for a lot of applications these days. The higher wattage power supply in this computer and the placement of that PCIe X16 slot make it really easy to toss a GPU into it so that you can game, and with a cheap CPU upgrade to something like an i5-11400F, you could almost certainly get a very solid gaming experience for not a crazy amount of money. Well, that's all that I have for you in today's video. I hope that you were able to at least enjoy it, and maybe even learn a thing or two. In any case, I hope to see you next time. Goodbye.